everyone. So today we have somebody joining in from Canada. I think you're from Toronto area,
Canada, correct? Yeah, yeah, Ontario. Yeah, I live in
Ontario
Ontario.
area. 200 plus leak code questions solved. Self-employed but actively looking, so starting to look for like fan companies and stuff like that. How many hard questions, medium questions, and easy questions have you solved?
Hard questions are probably done. I know it's less than 10 at least. Medium and easy is 100 and something.
100 something.
But like
Okay,
low hundreds. But I don't. I mean, I'll have to search that right now.
cool.
One sec.
Okay,
Let me.
so I'm gonna give you this question. So we're
Sure.
gonna be given a list of friends. It's gonna be like given a list of pairs of friends.
Okay.
So it's gonna be like a list, right?
Okay.
It's gonna be a bunch of friends. James, Isaac, Isaac, Nat, like random people, right?
Okay.
Maybe. So we're gonna be given a list of pairs of friends.
Okay.
Um, then we're after we're given a list of friends, we're gonna have like n queries where each query will ask what is the degrees of separation between these two people.
Okay.
Query is the degree of separation between two people. So that
Okay.
means like if me and you are directly friends, we only have 1 degree of separation. If
Okay.
me if me and you are friends through a mutual friend, we have 2 degrees of separation.
Okay.
Does that make sense? If
Yeah.
you're a friend of a
Yeah.
friend of
I
a
think it
friend,
does. Yeah.
yeah, exactly.
So like, what am I supposed to output?
So for each query, pretend we say James Isaac, right? We
Okay.
should we should output degree of separation, which is 1.
Okay.
What about James and Nat? How many degrees of separation is that?
So I think that would be two. Assuming like Isaac, well, in this array, assuming they're two different people.
Yeah, they're two different people. The names here are gonna be
Oh,
unique.
rather they're the same person. Rather,
Yeah, they're the
um,
same people. I mean, yeah, the names are gonna be unique.
right. Okay. Okay. Cool. Um, okay. I'll just wait for you to finish
Yeah,
typing
go
before
ahead.
I like.
I'm
Yeah.
just writing down some good shit.
Oh, okay. So like, so I'm assuming the names are unique, correct?
Yeah,
Okay. And then I would also be provided like two different names in like the method. I'm assuming, right? Right? Correct.
yeah,
So like essentially like to link both people together. So I'll be giving two separate names, and then I'm supposed to output the distance
yeah.
between them.
Exactly, exactly.
Okay, cool. All right, cool. I'm just gonna think for a second here. So essentially, this would be some form of merge sort, I guess. Well, not merge sort. Like we want to basically merge names together, right? And okay, so I'm just gonna do a bit of. Oh, so queries can contain multiple.
It's just gonna be a bunch of queries.
Gotcha, gotcha,
But like we're gonna be given two inputs: the friends and the queries. We're gonna
gotcha. Okay,
all we just need to do is loop through the queries, and for each query, like print out the degrees of separation between those two friends.
gotcha, gotcha. All right, cool. Sorry, I'm just trying to think here. So, and it's Gary. Okay, never mind, never mind. So I'm thinking we build like some form of hierarchy, right, for each name, and then plug them together, right, and then that way we are essentially able to iterate through queries where, um, yeah. So this is essentially going to be my approach, right? So we want to build a hierarchy. So I'm just gonna say build a hierarchy, hierarchy using a map, right? So for example, in this for these two examples you gave, right? So we're gonna have friend, rather not friend, James. James is going to link to multiple people. Well, it could be an array of objects. Now that I'm thinking about this, right? So we would say James links to say give it a name. James links to Isaac, right? And then in the next entry, we have Isaac links to uh, give it a name, say name, Nat, right? And then Nat links to an empty array,
Mm-hmm.
right? So essentially, the flow of things is then we would then, after we've built the hierarchy using a map, we'll then iterate through queries where for each name, right, we want to perform a DFS on the hierarchy map or the map, I guess, hierarchy map, whatever you want to call it. We basically do that, and then we then count. Actually, no. Now that I'm thinking about this, that would probably not work because it might give us a okay. No, actually, no, maybe that wouldn't work. Um, hmm. Let me think. Sorry, give me a second here. I'm gonna think out loud for a bit. So, if actually, better question: do you think building a hierarchy could work in this case?
Yeah, building a hierarchy by just using a bunch of sets, or like what do you mean by building a hierarchy specifically?
So, like it would essentially be like for each name, right? We want to pair them with all the people they're attached to, so friends. So in this case, James to Isaac, right? And then, well, actually, no, ignore it. I think I have a question here. So can we say, okay, so I know this example is rather simple, but can we have multiple um, instances where James is friends with somebody else?
Yeah, I could
Can
be
we
friends
have
with a
that?
ton of people.
Okay, he can be friends with a ton of people. Gotcha, gotcha. Okay, all right.
Like James, Patrick,
To Patrick, yeah.
Patrick to Paul,
Right,
Paul to Nat.
right. Um, hmm. So if we build a hierarchy, right? Now, if I say James, I want to get all James's friends, right? Yeah. So I'll stick with the approach I'm trying to explain it to you and see if it makes sense to you. So essentially, I'm going to build a hierarchy. For each name, I'm going to link um, the values. Well, because this is a map, so essentially the name will be the key, and then the value would be all their attached friends. So think of it like a hierarchy, right? And then I will then iterate through queries where for each name I would have to perform a DFS until I get the if or like I basically find a friend and basically calculate the distance there. Does that make sense?
Yeah, if we perform a DFS, okay. But what if we, for example, we're looking between James and Nat, right? I mean, there's
Okay,
multiple ways that I can get to Nat.
correct.
I can go James to Isaac, or James to Patrick, Patrick to Paul, Paul to Nat. That's like four.
Right. Maybe
Like the
hmm,
degree of separation is actually two, not four.
correct. So if we say James, okay, so we want to get the next pair, right? The next pair for James. This is a good problem. um, oh my goodness, I don't know why I can't think all of a sudden. So DFS would definitely building a hierarchy would probably not work. It wouldn't be the most efficient. Um, okay, so can we say we have Can I do a BFS on this matrix graph of friends? So say we have James, right? So James, we get all his friends, right? What are all James' friends? So we say Isaac, right? Patrick, and then um that's pretty much it, right? So from that point, we then just keep performing a DFS, but then or rather BFS. But then the issue then becomes for the queries can be n long essentially. You can have a shit ton of queries, so that would probably not be the most efficient. Hmm. 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 Yeah, actually, why am I worrying myself about efficiency? Can we instead just perform a BFS for say essentially what I'm going to do is for every query, right? I'll pull out the individual um names, right? And then I'll then need to actually no, that wouldn't work. That wouldn't work. That wouldn't work.
What wouldn't work?
Hmm. Performing so essentially for every query, right? I would have to plug out the names,
Yeah.
right? And
Yeah.
then get the associated um um name basically iterate through friends where the particular name I'm looking at or index of zero in this case, right? I would have to check all the friends where the index of zero matches the name, and then I'll then basically get the perform BFS on them, all the names. But then I don't think that would be efficient. Actually, do you understand? Did you understand what I just said?
You're trying to say that we can't do a BFS essentially?
I'm saying like, would it be the most efficient?
Well, like if we perform a DFS, the problem is that
No, BFS, breath
yeah.
first. Sorry,
So
yeah,
yeah, yeah. Like I understand. So yeah, what I'm saying with the DFS, you first the reason why you said you don't want to go with that is because you might return the wrong degree of separation, right?
correct.
Because um, and like why is that the case? Could you explain why you might return the wrong degree of separation?
Because say for every single entry in queries, right, I would have to iterate through friends and then get all the instances where the index of zero matches the index of zero of queries matches the index of zero of friends,
Mm-hmm.
right? And then insert that into a what's the word a queue, right? And
Mm-hmm.
then perform a BFS where I just basically pass the distance to the appropriate um no, actually no, that wouldn't work either. That wouldn't work either because I wouldn't have the instance of said name. Hmm. What am I missing? What am I missing here? What am I missing here? Hmm. What am I missing here? Could it be a thing where I can't possibly merge the names, can I? Like build some form of a linked list with these names? No? You think I could possibly do that for every single name? Right. I want to build like a linked list of all the friends. You think I can possibly do
Build a
that?
linked list of all the friends. What
Yeah,
what would
so
be the
like
use of that data structure?
so it would be easier to find all the names that are associated to every single query, the index of zero. So what I'm trying to get at is if I just do a simple diagram, right? So for say for James,
Yeah.
right, his attached friend would be Isaac, right? And then also no,
And
that
Patrick.
wouldn't work. Yeah, no, that it would also be Patrick too.
Yeah.
Maybe not a linked list,
Like
but
yeah.
basically just
Yeah.
an array of
Just an array.
names.
We just need to know for James these are its friends.
Yeah, these are all his friends,
Yeah.
right? And then for Now the thing is, we would then have to. I'm sorry, I'm just gonna type some things out and then try and make sense of
Yeah.
it in my head.
Oh.
Right. So Patrick. Now, better thing. Say in this example, no, Patrick is friends with Paul. Actually, no, never mind. I was ignore what I said. So let's just say Patrick. His friends are Paul, or rather James, Paul, James and Paul, I guess. Right? Correct?
Yeah.
And then for Paul, his friends are Patrick, Nat. And then for Isaac, we then have James and Nat. So if we build this, right, we essentially want to be able to find the associated friends. So for James, is he friends with Isaac or the distance, I guess,
Yeah. The distance.
but in this case, right, would be so for James to Isaac would just essentially return one, which is fair. Now
Yeah.
from James to Nat, right? So from James, we then pull out Nat, or rather, we see that Nat is in the array of friends. So we will then have to check every single friend. So for Isaac, right, we pull up, move on down to, or rather, we perform a BFS or DFS, I guess, right? And then, okay, so we see James again, but we have already seen James, so we ignore that or
Mm-hmm.
ignore his name, I guess,
Sure.
and then move on to Nat. So we have found an individual. So in our recursive call stack, it should return two, I think. Right now, let's move on to the next individual. Well, I guess those are the only two entries.
But what
But
if
then,
I
like,
go instead of Isaac? What if it was Patrick actually here first?
if Patrick was here first, so we would then have to go to for Patrick. Then we move on to Patrick, and then we check all his friends. We ignore James because we have already seen James, and then we move on to Paul, right? And then Paul leads us to Nat.
Yeah. But
But
then
then,
the
yeah,
degree of
that's
separation is too big.
it's yeah, exactly.
So
Degree of separation is three, but we want two. So in this case, um can we do something like instead of a DFS, can we perform a BFS, I guess?
like why
Because
would
the
that
BFS
solve
will
it?
get a BFS will get us the closest name, right? For I mean, like, yeah, I think it might get us the closest name, I think. But basically, we'll have to perform BFS on this angle and then passing the distance. So from Patrick to Isaac, right, we get James and Paul. We ignore Paul. Um, Now from Paul we get Nat, but we see that is three. Um, can we do something? No, that would. I might not know how to solve this question if in in the right time. Hmm,
Makes sense. Like
huh,
yeah, like the problem with the DFS is that if we do a DFS,
right,
it we might take a path that's too long, and we return the
correct.
wrong result. So breadth first search usually gets us the shortest path between two
Correct.
names, and then we just return that. So yeah, BFS makes sense to me.
Yeah. But then, like, the only question I have for that is how do you then keep track of the the weight of the distance? So do you
The
use some do you use like a priority queue for the as a queue when performing BFS? Do you
But
understand what I just said first?
no, I didn't get that. What did you say?
Oh, okay. So say in this case, right, if we're going to perform BFS on um for, between James and say Nat,
Yeah.
right? So we basically iterate through the closest friends to Patrick, or rather James. It would be Patrick and then Isaac.
Mm-hmm.
But then we pass the distance, which in this case it would be 1 to 1 for Patrick and Isaac,
Yeah.
right? Does that make sense? That's
Yeah.
what?
Yeah.
Right. And then from Patrick, we then move on to James. Well, we ignore James because we have already seen his name. And then we pass on two
Yeah.
to Paul because of 1 plus 1,
Yeah.
right? and then we then pop out of the queue and then handle Isaac, right? So from gotcha, I see that actually. I see it actually now. A BFS would work here.
Yeah.
Yeah, BFS. Yeah, this is a BFS question. Yeah, I see that now. I see that. I see that. I definitely see that. Yeah. I mean, I don't. Do I have time to implement?
Yeah, you have time. You have time.
Oh, okay, fair enough. So I could just jump straight to coding as long as
Yeah, go
you're
ahead.
already
Like
on
you're yeah. What?
it. Okay,
Yeah, go ahead.
fair enough. I'm just gonna call this solution, and then so say we are giving friends, and then we're giving queries, right? So what do we want to do? We basically want to build the this data structure, right? So I think I need a map here. So I'm just gonna call this cache, right? Actually, maybe I should use default. No, default dictionary. Yeah, I think it's default dictionary should work. Yeah. So okay, now I want to iterate through friends. So for friend in friends, um, yeah, for friends in friends. Actually, we could do this instead. So we can say first friend one, and then say friend two, right? And then what do we then want to do? So we basically want to build a thing. So we want to say cache dot friend one dot append friend two, and then we want to say cache dot friend two dot append friend one. So this is essentially just building the adjacency list. Hopefully this makes sense to you thus far.
Yeah, yeah.
Right. So now we then want to iterate through queries, right? To basically find the closest distance, I guess. So what do we then want to do here? So we want to define our query, or rather a queue here. So we're going to say DQ, right? And then, so what do I then want to do? So I want to say iterate through, say, F1 and then F2 in queries, I guess. So what do I then want to? I want to find the distance, right? Now that I'm thinking about this, how do I want to perform my BFS on this? Right. So I'll just do q dot append f1, I guess. It'll be a tuple. So let's just say f1, and then give a distance of initially 0. Then I'm then going to perform a BFS here, where I'm saying whilst our queue is not empty, right, I would define, I'm going to call this friend, and then distance, I guess. Call this equal to q dot pop left, I guess. Let me think about this properly first. So we have set individuals. We have set individual, right? So the friend and then F2. So what do we want to do? We want to perform a BFS on these names.
Mm-hmm.
So how do I do that? Instead of appending the name, I would have to append all his friends. Correct? Instead. So instead of doing this, it would have to be so for say cache dot f1. Let's do friend.
One piece of advice here would just be probably pull out the BFS into its own function.
Into its okay, fair enough. Fair enough.
Because you're gonna perform BFS for every query.
For every single query, yeah. That was my worry initially, because like that might not be the most efficient, but who cares, right? So let's just do cache, and I need f1, and then let's just say f2. Right. So now what do I then want to do here? So I essentially then want to say, okay, cool. Now that I have the friends, I'm gonna append first of all, I need to clear the queue just in case we have items in the queue already. Then I want to then append. Actually, I don't have the instance of the queue. Okay, so what do I then want to do?
Why do you need to pass in a queue there?
Because I am performing BF. I mean, unless I'll have to create a new instance of the queue every single time.
Mm-hmm.
So that's the reason why I'm clearing the queue, so I don't have to create a new instance. Does that make sense?
Yeah, but if we need a brand new one every time, why not just create it?
Yeah. Oh, okay,
It's
fair
gonna be
enough.
empty.
I mean, yeah. Okay, that's fair. And then, okay, so now that we have our queue, hopefully I'm still within the time frame. Okay, so what was I doing? So I basically want to then append all the friends into the queue whilst passing the keeping track of the distance. So I'm just gonna iterate through cache. Let's do f friend in cache of f1, and then we can then say q.append. Excuse me, append f, and then give a distance of initially 0. So now that we have this, so I'm then going to say whilst we have a value in our queue, right, I want to pop out the friend. I'm going to give this a friend, just call it f, and then the distance, right, equal to q.pop left. Right now, I then check the case if f is equal to f2. I'm just going to return the distance. Else, I basically want to then perform a BFS on every single friend's friend or friends. So what do I then do here? So I basically say friend, gonna call this a neighbor in cache of f. I also need a scene equal to sets. Actually, now I'm thinking about it, I can just pull this down like this. So now that we have this, oh my goodness. So now that we have this individual, what do we want to say? So if f in scene, we're just going to continue because we don't want to, search the same friends.
Sure.
I'm also going to do this for this also. I can call this neighbor instead. Right. So now that we have the friend, so we're basically then going to append it into our queue.
Mm-hmm.
Right. Which would be q.append. I think I've seen an optimization I can possibly do here even. So we can then do the distance plus 1. So I think this should return the answer. The optimization I actually just thought about was what's the word? So instead of this, because it's not gonna matter because we're not gonna add this. I'm gonna move this also, and then I'm just essentially going to do if f, or rather, should it be f or neighbor? Actually, no, I'm just gonna leave it the way it is, right? And then just leave it the way it is like this, right? Yeah. So this would definitely be my solution. I'm gonna carry on with the just the final few bits, and then perform a BFS on right hand side. What am I passing in cache? I'm passing f1 and f2, right? And then I'm assuming the results should be an array of items, correct? Or array of distances, correct?
Yeah.
For every single query. Okay, cool. And then I have my results is equal to an empty array. Just gonna return this. Call this our results. And then now that I'm actually deep in this, it should probably be yeah. So this would be a return value, and I can just do res dot pen this value. Does this make sense thus far?
Yeah, it makes sense thus far.
Right, it should be default. I think this is how. No, maybe it's this way. Right, and then yeah. So this is this would be my solution to the problem. I don't know if you want me to dry run the code.
Let's actually just run it through some inputs and assert that
Sure,
it's correct.
sure. Okay, cool. Fair enough. So I'm just gonna do print solution, and then gonna call this friend, and then Q. I'll just define the and then Q. Let's go to this. And then the examples you gave were these. Nothing here. Give me a second here. Just like this. There we go. And then so the expected outputs in this case should be 1 and 2. Okay, so it says F1 append. Okay, so where maybe default, I forget the, am I allowed to look up the API? I could do something similar to this, but then that would be
Just like this.
yeah. I was gonna look up the API. Yeah. Thanks. Yeah, list. Yeah, there we go. So that should be
Off.
okay. So it's off. Okay, so let me do a bit of debugging here. So just make sure this prints the expected output here. Let's just make sure. So we have James to Isaac, Patrick. Cool. All right, cool. So the problem then boils down to my BFS function. All right, cool. So looking at this, right? So I then append for every single name for the associated friend, right? I need to get all the friends, cool, and then I iterate through the distance or iterate through the queue, and then basically check all the neighbors. Okay. So now I'm just do if not in scene dot add. I think this was where the issue was. And then I also need to actually no. This I think I've seen the error here, so this should be down here because I'm revisiting old names, I feel. So let's see.
I don't think that's the error.
Okay. What was the output? Okay, it's still the same thing. All right, cool. So I have my okay. Loop through the neighbors. If neighbor not in scene, I can then passing into our queue. Cool. Pen of friends. Cool. Okay. So what is this queue looking like initially? What is this looking like initially? So we have Isaac, Patrick, Isaac, and then Patrick. Cool. So that isn't what I want. Wait, give me a sec. So James to Isaac, and then James to Nat. Looking at this, James to Isaac should be okay. I think I've seen the problem. So we should start off with 1 instead of 0. I think. So I think that's where the problem is. So it should be 1 to 2. Okay, cool. This I think this looks about right. I'll try for a different example here. So say we have just say we're say James is not friends with Nat, I guess. So let's just take this out. James to Isaac, and then James to. Actually, I don't know if I should make my own examples. It should be you. No, no, I'm
No,
actually
you should
thinking
make
that.
your own example.
Oh, okay, fair enough, fair
Just
enough.
test it and make sure that it's working correct.
Yeah, okay, fair enough. So essentially, James to Isaac, right, should return one, right, and then James to Nat should be zero. So the expected output should be 1 to 0. Okay. Instead of none, I see. So this should be I see. I see what my problem is. I return a base case here. It should be 0. Right. Yeah, so this is then the expected. So yeah, this would be my final solution, even though I had a lot of hints from you.
Yeah.
But yeah, so this is my final solution for sure.
Nice. Yeah, it's looking good. It's looking good. Let me think about this. Yeah. So maybe one follow up would be um pretend there was I don't know if I would follow.
I mean, maybe actually, a question I should have asked earlier is: it's not possible for James or for a person to be friends with themselves, right? So like,
Yeah.
I should have clarified that, but I don't know.
Yeah.
If, yeah, I should have
Yeah.
clarified that.
Okay.
Yeah.
Cool. All right. How do you think you did? How was that?
Um, yeah, I need a bunch of hints.
Yeah.
I don't know. I feel like it's just because I was yeah, I honestly have no as far as my feedbacks, if anything, like I should do maybe attempt more questions, I guess. Maybe communicate better. I think, but I don't think I did that well, to be fair.
Yeah.
I
I
don't think I
think
did that
the
well.
main thing you could improve on here is you should when you start reading through the question you and it says degrees of separation or like they're showing relationships between two elements or two people. You should start thinking about it as a graph question right away. And I think you had trouble identifying that at first.
Yeah.
So this is a graph question because like if you come into the drawing,
Just give me a second. Yeah. It's loading up. Yeah, I'm on the same page.
like this is a graph question because yeah, every person is a node in the graph. James, right?
Right.
Isaac, Patrick. Oh sure. Like everybody is a node in the graph. Patrick,
Right.
Paul, Nat. So it's like a bidirectional. It's
Relationship.
usually a
Yeah.
bidirectional relationship between each person in this graph.
Right.
And it's like a let's say we have this. So once you can visualize in your head that this is actually a graph, then you need to start figuring out the degrees of separation. Between James Isaac, it's 1. Between James and Nat, is 2. So I think the first step is identifying it's a graph problem faster, and just
Right.
like visualizing the graph in your head. And after
Right.
that, yeah, like you explored, oh, maybe we need to do a DFS. Okay, if we do a DFS, but what if we are looking for James and Nat, and we go the long way, right?
Right.
So yeah, and then like what I think for me when I visualize that it's a graph in my head, then I need to figure out like even if I just drew out the graph like this, then I know okay James and Isaac in order to find the shortest path, we just do a BFS. So it took you a while
Right.
to just determine that we actually need to do a BFS in
Right.
order to
Yeah.
solve it, and I think it just stems from just like not identifying it's a graph problem right away.
Right. Yeah. No, honestly, I should have clocked that it was a graph problem because they said or rather, a BFS off the top because they said the shortest path.
Well,
Right.
I
So
just
like,
said degrees of separation, so it's not really shortest. Like I didn't directly say the shortest path between two. Otherwise, you would have thought BFS right away.
yeah. Yeah. No, I mean, like, I'm just saying, like, I should have clocked that, but either way, like, this was good though.
Yeah,
This was really good. Yeah.
I think you learned a lot from last time too, like building out the adjacency list and yeah.
Yeah.
So BFS was
Man, I
pretty
should have
good.
knew that would have been the same question you would ask. They'd be in the
That's a
same
good question.
topic. Yeah. But yeah, that's fair. This was good though. This was good.
Cool. Yeah.
Yeah.
But honestly, yeah, good clarifying the questions, figuring out all the different constraints, like the names being unique, like the different queries. Um, yeah, just ironing out the requirements of what even is a degree of separation and the input. I think
Right.
I gave you some prompting to like break out the BFS into its own function. So
Right.
if you're gonna perform a thing multiple times, might as well break it onto its own function and have it isolated. Like
Right. Yeah.
you did a
True. True.
weird thing with you're passing in the queue and clearing it, but really each
Yeah.
BFS should just act unique. It's like should be like a unique call, and it shouldn't
Yeah.
reuse data structures. It shouldn't reuse like values from a previous run because the previous run didn't doesn't really matter for the current run.
Yeah. Yeah. No, that's completely fair. Yeah. I mean, like the way I was just going to approach it before, it was just clear the queue every upon every iteration or the set.
Yeah,
Clear both of them every iteration.
yeah.
But yeah, I can see I see that for sure. I see
All
that for
right,
sure.
cool.
All
All
right,
right,
man. Yeah,
thanks for
this
hopping
this is
on.
good
Yeah, let me
for
know when you
sure.
want to do another one. Just schedule one through. Like you're honestly getting better by
Yeah,
each
for
time.
sure.
Like so, cool. All right, see you, man.
All right, yeah, peace out, man.
All right, chat. That was 4 interviews in one day. We're man, that was fun. We got a lot more tomorrow. I gotta do some prep. I gotta do some prep for some people we have on tomorrow. Um, tomorrow I have a tomorrow I have a special guest. So one of my friends, when he went to University of Pennsylvania, and while he was in school, he started a startup with some of his other friends and sold the startup while he was in school to Lyft. So he already had a successful exit before he left school, and then he came to Silicon Valley. That's how I know him. I worked with him at my first job. Then he moved to Airtable and is working on he's working on AI. He's an AI engineer now. So he transitioned from a SWE to an AI engineer. This is he's not he does I don't think he does code forces. So we're gonna figure out what topics to talk about. Um, yeah, but Josh, did you book with? Yeah, second was Alpha. Josh, have you booked at all? Oh, who's the most cracked so far? Alpha's up there for sure. Obviously, Code Forces guy. But Code Forces guy doesn't really do the lead code questions. So if you ask him some lead code questions, he might not know it. He'll be able to do it, but um, the type of questions Code Forces ask versus lead code are very different. But anyways, all right. Anyways, chat. Thanks for hopping in. That was that was that was a good stream. We'll be on again tomorrow from we'll be on tomorrow from 5 to 10. Yeah, and we got a bunch of people. We have that. I'm bringing on that AI engineer. But yo, thanks everyone for coming out. If please like if you find any good interview questions that people are actually being asked, send it to me. Maybe I'll make a new chat in the Discord where people are posting real interview questions that are getting asked and not just like these random like lead code competition ones that are kind of whack. But thanks for tuning in.